Hi, my name is Kai. I'm a software developer and business analyst, and I've been following IOTA since 2018. In this video, I will provide you with an overview of how you can integrate Rust libraries from Shimmer and IOTA into Flutter. This integration will enable you to create apps for both mobile devices and desktop environment. First, I will provide a clear explanation of the workflow steps involved. I will then proceed with a quick app creation, showcasing how the process comes together seamlessly. But first, let's take a moment to understand the context. Our goal here is to empower individuals by enabling them to utilize the IOTA and Shimmer network through an app. Here's a simple example: an app with just a button and a text field. When the user clicks the button, it should establish a connection to a Shimmer node and retrieve information about it. This information will then be displayed in the text field. Within the application itself, the following occurs. In the front end, when the button is clicked, it triggers its handler. This handler utilizes a method provided by the Foreign Function Interface, FFI. FFI is a mechanism that enables programming languages to call functions from libraries written in a different language or execute code written in a different language. In the context of Flutter and Rust, FFI facilitates communication between the Flutter front-end and the Rust back-end. Essentially, the button handler invokes a Rust method. This method then forwards the request to a function in the IOTA Rust library, which retrieves the desired information from the node. The information is then relayed back using the same pathway. During the development phase, this means that the UI and handlers are written in the Dart programming language, while the back-end functions are implemented in Rust. This separation allows for leveraging the strengths of both languages: Dart for the front-end user interface and interactivity, and Rust for robust back-end functionality and integration with libraries like IOTA. During the build phase, the Rust code is compiled into a library that is then incorporated into the Flutter app. The entire code base is compiled into machine code that can be executed on the target platform. In order to get a better understanding of the IOTA library, it is important to know that each node also provides an API. This API allows developers to interact with the node and perform various operations, such as getting information, sending transactions, and querying the network. There are even multiple APIs, but we only focus on the core API. I would like to briefly demonstrate the ways in which one can interact with Node API. To illustrate this, I will focus on the endpoint used to retrieve node information, as that is the specific information our app intends to display. The first option is to use a browser-based Swagger page. You can access the Swagger page by starting from the Tangle Improvement Proposals website. Select Core REST API. Once the Swagger page is open, you will have a comprehensive overview of the available endpoints. You can modify the URL of a node and then test the endpoints to interact with the API. If you execute this endpoint, you will see the result that we expect also in our app. The second option is to use a REST client such as Postman. Postman is a widely used and freely available tool that is compatible with various operating systems. You can type in the URL of the endpoint and send the request to the server, so you will also get the same result. Finally, we have the Rust library iota.rs, the IOTA client, which internally makes use of the Node API. As you can see, it is available in various versions, with version 1.4 supporting Chrysalis, the protocol version of the IOTA mainnet. Versions 2.0 and above are designed for Stardust and enable the interaction with the Shimmer network. After this brief detour, I will now explain each individual step required to create the app. I will assume that all the necessary tools are installed and up to date, and that in itself is no small feat. I will delve into the details at another point. The initialization process starts with creating the Flutter project. Flutter generates a project folder with target folders for all supported platforms. The source code resides in the lib directory containing a default application. In step 2, a Rust library project is created, which adds another directory named Rust to the existing Flutter project. This Rust directory serves as the location for writing the Rust code. The most extensive part of the initialization process is setting up the Flutter Rust bridge. The Flutter Rust bridge is responsible for generating the Dart interface from the existing Rust code. The Flutter Rust bridge is an actively maintained GitHub project. It's continuously developed and improved by a dedicated team of contributors. This project serves as a reliable and robust solution for integrating Rust code into Flutter applications. There's a very comprehensive user guide containing articles about special topics and a lot of information how you have to set up your working environment and how you can support different target platforms. Now let's focus on the actual development work. Please note that the following is just one approach and every developer may have their own preferred method. Initially, the Dart code for the user interface is created without any backend integration. This step involves designing and implementing the UI elements such as buttons, text fields and layouts to create the desired visual and interactive experience for the app. In the next step, the Rust developer creates the signature for a method that needs to be exposed in the API. He then incorporates the IOTA library and writes the necessary business logic code. Then it's time to generate the Dart interface code. After this brief and amusing interlude, the developer is left with just one task: integrating the foreign function interface calls. After all is said and done, we arrive at the most exciting and nerve-wracking part. It's time to build and run our creation. Before diving into the demo, let's take a moment for a brief summary. Before we begin, let's make sure our systems are up to date. On the Flutter side, we'll run Flutter Doctor, on the Rust side, Rust Up Show. To create a blank Flutter project, use this command. The next commands I will execute in Visual Studio Code. Next, I will generate the Rust library project. The workspace is now equipped with all the folders I need. During the setup of the Flutter Rust bridge, we first add the necessary dependencies for Flutter and Dart using the flutter pub add commands. Additionally, we configure the dependency for Rust in the cargo toml file. Afterward, we need to configure the Android project to ensure that the Rust library is automatically cross-compiled into the desired target during the Gradle build process. To expedite the build process and save disk space, I will add only the target that corresponds to my virtual device. Now the fun part begins. In the main Dart file, I replace the default code with a prepared script. I need to add a dependency to enhance the display of my JSON result, which includes the node information, in a more aesthetically pleasing manner. Let's take a look at the app now. The backend call is mocked, meaning that instead of making a real request to the server, a simulated response is generated. Later on, I will replace the dummy data with the actual results obtained from the real FFI call. The first step on the Rust side is to include the IOTA client library and other necessary resources. I will choose the latest version, which is release candidate 7 of version 2.0.1 for this purpose. It's compatible with Stardust, so in my prepared API script I select the Shimmer test network. Lastly, I include the API file in the main file lib.rs. Generating the Dart interface is a breeze. The process involves automatically generating several files that are then added to the workspace. Integrating the library involves loading it into our project, enabling us to execute its methods and utilize its functionalities. In the main.dart file, the final step is to insert the appropriate function call to invoke the desired method from the library. We're done. Let's start the app and retrieve and display the node information. Thank you for watching. If you like the video, give it a like. If you have questions or remarks, leave them in the comments below. And if you like, follow me on Twitter or YouTube.